Good day, Damians! So we will be talking about circle for this week. This is your teacher, Miss Mary Christine Camuzo Antolan, LPT. Enjoy learning! So we will have 3 goals for this week's lesson. These are, at the end of the lesson, you are expected that you can write standard form of the equation of a circle given a radius and a center and a point on a circle, and an equation of a circle that is not in standard form. Also, you are going to sketch a circle given the standard form of the equation of a circle, and lastly, you are going to find the intercepts of a circle. But before anything else, let's have first a review on the topic that we have discussed last week. So we have discussed about a circle, which is the set of all points xy in a plane that are equidistant from a fixed point called center, which has the coordinates hk. We also have discussed about radius, and radius is the distance between the center hk and a point on a circle, which is xy. So we have this formula in finding the radius of a circle given the center and a point on a circle. So we have the square root of x minus h quantity squared plus y minus k quantity squared, where x and y are from the point on a circle and h and k are from the center of our circle. Lastly, we have sketched a graph given a radius and a center. So let's get started. Let's start with the standard form of the equation of a circle given a radius and a center, and given a radius and the center which is at the origin. So the standard form of the equation of a circle, if we are given a radius and a center, is given by the equation x minus h quantity squared plus y minus k quantity squared is equal to r squared. So h and k here is the coordinates of our center, and r here is our radius. On the other hand, if we have a radius and a center at the origin, we will follow this equation: x squared plus y squared is equal to r squared. Now let's go to example number 1. You are tasked to give the standard form of a circle given a center and a point. So it says that a point 1, 4 is on a circle whose center is -2, -3. Now, write the standard form of the equation of a circle and sketch its corresponding graph.
So now we are given the center, which is at point -2, -3, and a point on a circle which is 1, 4. Now we are going to solve or to give the standard form of the equation of a circle, and we all know that the equation of a circle is given with this equation:
x minus h quantity squared plus y minus k quantity squared is equal to r squared.
So the problem here is that we should look first for the radius, because we have the value of h and k already, which is our center. So we have to look first for the radius, and to solve for the radius, we have to use the distance formula.
So the radius is the distance between a point on a circle and the center of the circle. So given those 2 points, the xy for the point on the circle and hk for the center of the circle, we can solve for the distance or the radius using this formula, the distance formula. So solving for the distance or the radius, we just have to substitute the values of x and y, which is from the point on the circle, and the h and k, which is from the center of our circle.
So substituting, we have for the x, we have 1 minus the h, we have -2 quantity squared, plus we have the value of y, which is 4, minus the k, which is -3 quantity squared. Okay, so simplify this one. Now we have 1 minus -2 quantity squared. So 1 minus -2 will actually become now 1 plus 2, Why? Because we have a double negative here, which will result to positive. And then we have plus 4 minus negative 3. Same with what happened here. We have 4 plus 3. Okay, why again? Because we have a double negative here that will result to positive. So we
end up having square root of 1 plus 2 quantity squared plus 4 plus 3 quantity squared. Okay, so we have now the square root of 1 plus 2, that's 3, and then squared, we have 9. Here we have 4 plus 3, that is 7, squared, that is now 49. So we have r, or the radius, is equal to the square root of 58.
We will now substitute the value of our radius square root of 58 into our equation. So let's have first x minus h. We have x minus the h, which is from the center of our circle, negative 2. Quantity squared plus y minus k. And our k here is negative 3. So we have negative 3 quantity squared is equal to r. So our r a while ago is square root of 58. So we will substitute square root of 58 into our r, and then we will square it. So we have square root of 58 squared. Okay, so let's simplify this one. This will now become x. Again, we have a double negative here, so we have plus 2 quantity squared plus we have y, a double negative, so we have plus 3 quantity squared is equal to, we have square root of 58 being squared or being multiplied to itself. So that is now 58.
So we end up having the standard form of the equation of a circle, which is x plus 2 quantity squared plus y plus 3 quantity squared is equal to 58, given the center at negative 2, negative 3, and a point on the circle, which is 1, 4.
So there you go. The standard form of the equation of our circle now is x plus 2 quantity squared plus y plus 3 quantity squared is equal to the r squared, which is 58. So there you have it. I've used here the GeoGebra app and graphing our circle. So we have the center, which is negative 2, negative 3, and we have a point on the circle, which is 1, 4. For the second example, you are tasked to give the standard form of a circle given a center and a radius. So this is quite easy because we are already given the center of the circle and its corresponding radius. So we don't have to solve for anything anymore, but we just have to write the standard form of a circle.
So here we will just have to substitute the given center and radius into our standard form of the equation of a circle, and then that's it. So we will have now our h, which is 3, and then we have our k, which is 7, and then our radius, which is 4. So we will just substitute these values, and then we will have now the standard form of our equation of our circle. So we have x minus the h, which is 3, quantity squared, plus y minus the k, which is 7, quantity squared, is equal to, our radius is 4, and then we will square it. So we end up having x minus 3, quantity squared, plus y minus 7, quantity squared is equal to 16.
So this is now the standard form of our equation of our circle, whose center is 3, 7, and whose radius is 4. Now we may proceed now in graphing this circle.
So there we have it. This is the graph for our circle 2. So we have the standard form, which is x minus 3 quantity squared plus y minus 7 quantity squared is equal to the r squared, or the radius squared, which is 16. So the center of our circle is 3, 7, and if you may have seen here, we have the radius connecting the point 3, 3, 7, which is the center, to a certain point here, which is point A, and radius here is equal to 4. For the third example, you are tasked to sketch the circle given by x squared minus 6x plus y squared minus 2y plus 6 is equal to 0, and identify its center and radius. Okay, so this equation here is not in standard form. So what are we going to do is first to give the standard form of the equation of a circle, and then let's identify its center and the radius, and then let's sketch the circle or the graph of the circle.
Now for the third example, we are given the equation of a circle, x squared minus 6x plus y squared minus 2y plus 6 is equal to 0. So the instruction is that we have to sketch the circle given by this equation, and then we have to identify its center and radius.
So identifying the center and the radius of this circle here is just like looking for the standard form of our circle.
So the standard form of our circle, which is given by the equation x minus h quantity squared plus y minus k quantity squared is equal to r squared. Here we have h and k, which are the coordinates of our center. And we have here also the radius, which is of course our r. So we will be changing this equation into standard form. So doing that, we will be having the process of completing the square.
So we will be doing the process now of completing the square, but before that we have to identify first, or we have to separate first all those terms in our equation here which have the variables on the left side of our equation, and all those terms which do not have a variable on the right side of our equation.
So we end up having x squared minus 6x plus y squared minus 2y on the left side of our equation, and negative 6 on the right side. So why this became negative 6? Because it's positive from the left side, and then we transferred it out to the right side, which is now negative 6.
So we would express this into a quadratic, which is a perfect square trinomial. So expressing this into a perfect square trinomial, we will be doing the completing the square process. So what's completing the square and why it's necessary?
So we will express this into perfect square trinomials. So what are perfect square trinomials? So these are quadratics, which are the result of squaring binomials.
Doing that, we have x squared minus 6x here, and then we have to look for the third term, which will make this as a perfect square trinomial. So we have to group this, and we also have y squared here minus 2y plus the third term which we are looking for. And we have here, of course, the negative 6 plus. So we have to remember that the terms here that we will have should be added also on the right side of our equation. So we can get the third term here by dividing this b, or the linear term of our quadratic equation, by 2, and then square its quotient. So say for example, we have here negative 6, the b, or the linear term, divide this by 2, and that will become negative 3. And then square the quotient, which is negative 3. That would be negative 3 multiplied to negative 3, and that is 9. So we have here, on the other hand, the b, or the linear term, which is negative 2. We also have to divide it by 2. So the answer is negative 1. And then we have to square the quotient, which is negative 1. So we will have negative 1 multiplied by negative 1, and that is 1. So we have added here the terms 9 and 1, and that should be added also on the right side of our equation. So we have here plus 9 and plus 1. So this is now a perfect square trinomial whose factors are x minus 3 squared. So why x minus 3? Because when we multiply x minus 3 by itself, we will end up having x squared minus 6x plus 9. And we also have here the y squared minus 2y plus 1 is a perfect square trinomial whose factors are y minus 1 quantity squared. So when you multiply y minus 1 by itself, you will end up having y squared minus 2y plus 1. On the other hand, we have negative 6 plus 9 plus 1, or that is negative 6 plus 10. Now negative 6 combined 10, that would be 4.
So this is now the quadratic equation of our circle in standard form. So out of here, let's identify the center and the radius. So the center has coordinates hk. And of course, we have the radius, which is r.
So we have here x minus 3 quantity squared is actually equal to x minus h quantity squared. So from that, we can identify that 3 here is actually our h. So therefore, we have here 3. Now let's identify the k. So we have here plus y minus k quantity squared. So actually, our k here is 1. So we have here the center of our circle hk is equal to 3, 1. And of course, we have here is equal to r squared. So 4 here is our r squared. So since we are just looking for the r, we will extract the square root of 4 to get r. So r is equal to the square root of 4. Now r is equal to 2.
So you might be wondering why we are just taking the positive value here for our radius. Again, radius is a distance. So when we say distance, there's no negative value for a distance. That's why we will just take the positive 2 for our r. Thus, our r here is equal to 2.
So here it is. This is now the graph of our third circle, which has the standard form x minus 3 quantity squared plus y minus 1 quantity squared is equal to 4, which is our r squared. So we have here the center of our circle is at 3, 1. And we also have the radius, which is 2. So this is now our circle 3. Lastly, let's have example number 4. Let's find the x and y intercepts of the graph, which has the standard form x minus 4 quantity squared plus y minus 2 quantity squared is equal to 16, which is our radius squared.
So looking for the x and y intercepts would be easy if we are having already the standard form of the equation of our circle. But if not, we have to change that equation first into standard form, and then let's look for the x and the y intercepts.
So since we are given here the standard form of the equation of our circle, we will now directly look for the x and the y intercepts. So looking for, let's have first the x-intercept. So in looking for the x-intercept, we have to zero the y value.
So here we have x minus 4 squared plus the y now will be 0, and then we have minus 2 quantity squared is equal to 16. So now let's simplify this one. This will become x minus 4 squared is equal to 0 minus 2, that is negative 2, and then squared, that is 4, is equal to 16. Now we have x minus 4 quantity squared is equal to 16, and then we will transfer 4 to the right side of the equation. That will now give us negative 4. So we have x minus 4 quantity squared is equal to 12. Now, you don't have to square this anymore because we are just looking for the x value. So instead, you have to extract the square root from it, and then we have here x minus 4. And on the other hand, we have here the square root of 12. Now the square root of 12 is, or this is equal to square root of 4 times 3. Now 4 here is a perfect square, so we can extract its square root, positive negative 2 square root of 3. So we have now x minus 4 is equal to the positive and negative 2 square root of 3.
So since we are just looking for x, we have to equate x is equal to, we have to transfer negative 4 into the right side of our equation. So we have now positive 4. So that will now become 4 plus minus 2 square root of 3. So we have two values for x here. The first value, or the x sub 1, is 4 plus 2 square root of 3. And the other value is 4 minus 2 square root of 3. So these are now the x-intercepts of our circle. So let's now look for the y-intercept.
So looking for the y-intercept, we will now substitute 0 into our x. So to do that, since we have x minus 4 here, we will have 0 minus 4 squared plus, of course, we have y minus 2 quantity squared is equal to 16. And then solve for y. So we have negative 4, 0 minus 4, or that's negative 4 squared, that's 16. And then we have here y minus 2 squared is equal to 16. Okay, so we have here y minus 2 on the left side of our equation, and we have here 16 minus 16 on the right side of our equation. So we have here y minus 2 quantity squared is equal to 0. Now, since we are just looking for y, we will extract the square root here and also extract the square root on the other side. So we end up having y minus 2 is equal to 0.
So looking for y, we have y is equal to 0, and then we will transfer negative 2. This will become positive 2. So y is equal to 2. So we have one value for y-intercept here, and this is y is equal to 2.
So here we go. This is now the graph of our fourth circle, which has the standard form x minus 4 quantity squared plus y minus 2 quantity squared is equal to 16, which is our r squared. So we have here points A, B, and C. So point A is here, point B is here, and point C is here. So point A is our y-intercept. So you may notice that our circle here intersects the y-axis at this point, which is our y-intercept. Also, we have here our x-intercepts points B and points C. So the coordinates of B is 4 minus 2 square root of 3, 0. While for C, we have 4 plus 2 square root of 3, 0. So there you go. I hope you can now write standard form of the equation of a circle given a radius and a center and a point on a circle, and an equation of a circle that is not in standard form. And I hope you can also sketch now a circle given the standard form of the equation of a circle, and of course find the intercepts of a circle. So this has been your teacher, Mary Christine Gamuza Antolan, saying thank you and keep safe, Damians.